Hello friends, very good evening. Myself Dr. M.H. Annaya, and in today's video we are going to study about the development of lateral surface of a hexagonal pyramid which has its base edges measuring 30 mm and the height 60 millimeter. That is from the vertex to the center of the base we measure the height or the axis length. Excuse me. So it is resting on its base on HP with an edge of base normal to VP. Friends, basically there are two stages involved in the development of any of the lateral surface of a solid. So first of all, we have to place the solid on HP to the given condition in the question. So in this question he says a hexagonal pyramid having dimensions so and so, resting on HP on its base with an edge of the base normal to VP. Friends, suppose this is one edge containing this triangle is perpendicular to VP or normal to VP. So we'll place it on HP such that when one of the edges parallel to VP, we will write down what is the top view. So top view is going to be a regular hexagon with the center O or the vertex O joined to all the corners. And in the front view, friends, you are going to see one, two, two triangles you are going to see, only these two triangles. So friends, we will start the development by drawing the XY line, that is the line of intersection of VP and HP. We will call it as XY and we will mark VP and HP indicating first angle projection, and we will just mark a hexagon in the top view having side is equal to 30 mm, and we will join the opposite side corners to get O, the vertex of the solid. So this is O, and we will mark these corners as A, B, C, D, E and F. Friends, here the dimension given is 30 mm. That is the pyramid having the side of base 30 mm. And friends, corresponding to this top view, let us obtain the front view. So by projecting lines from here, from this point, from this and this, you will get here the center line and mark the given height of the solid as 60 mm. So I'll write a line here and say this dimension, that is the height of the solid or length of the axis, is equal to 60 mm. Friends, here you have got A dash, B dash, this is C dash, F dash, and the last line is D dash, E dash. So we'll join this vertex O dash to all these points in the base. So I'm going to join O to A, then O to B, O to C, O to F, O to D and O to E. Friends, here this O dash, O1 dash represents the axis which is having 60 millimeter length. So for the given condition, this is the front view of the solid and this is the top view of the solid. Friends, in the second stage or step number 2, we are going to find out the true length of this slant edge. And as you see in the top view, all these base edges are of length 30 mm. They show the actual length or true length. And to draw the development, we need to have the true length of all the 6 slant edges. You know very well, they all will have the same length. So friends, here, let us find out the true length of this slant edge. So how to obtain the true length? Friends, if you observe the top view, none of these slant edges, OA, OB, OC or any of these are not parallel to VP, and hence none of these slant edges OA to OF give you the true length of the slant edge. So what is to be done in such cases? I am going to draw a horizontal line through the vertex. Make one of these slant edges parallel to VP. So I take O as center, OD as radius, and I am going to draw an arc. So I am going to get an arc here, draw an arc, and produce that arc upwards. So by making this horizontal, I am making the slant edge parallel to VP to obtain the true length. So friends, we will call this as D1 dash, and this is D dash E dash or E dash D dash. Friends, let us join this D1 dash to the vertex, say by a dotted line, and this line will represent the true length TL of this slant edge. And here I have to mark D dash, E dash. This is D dash, comma E dash. Friends, we have got the true length, that is O dash to D1 dash is the true length. So using that true length, let us commence the development of the lateral surface. Friends, I take a measurement O dash D1 dash equal to this true length, and I will call this as true length. Mark O, the vertex of the solid. Once you have the true length, friends, you can draw an arc taking O as center, true length as radius. I am going to draw an arc here, and on this arc I am going to step off 6 steps of this 30 millimeter, that is 30 mm, 30 mm, 30, 30, 30, and say this is again 30. So 1, 2, 3, 4, 5, 6. We have got 6 marks made on this, and all this will have a length equal to 30. 30, 30, 30, 30. And friends, you remember that all these pyramids will have straight edges, bottom edges. So I am going to join by this thin line, thin line, thin line, and finally this as a thin line. Join this O to all these. This is to division 1, division 2, 3, 4, 5, and 6. Next comes, this is the development, friends, of the lateral surface when the solid is not cut by any section plane. Now let us mark the section plane. The section plane is normal to VP, normal to HP, but not base normal to VP, cut by a section plane which is normal to HP. The section plane is vertical, normal to HP, and at a distance of 10 millimeter. Is it 10 mm? Yes, 10 millimeter from the axis. So whenever the section plane is perpendicular to HP, this is seen as a line in the top view. So friends, I am going to mark here from this vertex or the axis O1 a distance of 10 millimeter. So this line will represent the section plane SS, which is at a distance of 10 millimeter from the axis, that is 10 mm. So once you have this drawn, let us see what is the portion that is left for the development of the solid. So this is the portion that is retained for the purpose of drawing the development of the solid. So I will show all those lines by visible lines up to here, is up to here. And friends, if you see the top view, the section plane SS is cutting the base edge AB here, base edge ED here. There are 2 points on that, and also it's cutting the vertical edges, the slant edges at these 2. So totally there are 4 points, 2 on the base edges AB and ED, and 2 on the slant edges OB and OD. Friend, this is the portion that we are going to retain for drawing the development, and the lower part we are going to throw out. So friends, here, whatever the portion of the pyramid I have shown in dark lines is going to be developed here. Okay, friends, if you see here, none of these slant edges are totally removed from the solid. That is, if you take OA, it is fully available. OE, OE, OF, OD, a part is cut here. So you can start the development from any one of these. So say I am starting from this edge OB, sorry. So I'll start from OB and then come C, D, E, F, A and again B at the end. So we have marked the section plane, we have got to mark all the points where the solid is being cut. Friends, let us first of all mark the point on the base edge AB. AB is cut here by the section plane. Mark on AB the small gap nearer to B. On AB nearer to B. So we have a point here. Similarly, on ED nearer to D. On ED nearer to D, we have the second point. Excuse me. So these are the 2 points. Similarly, friends, you have on the slant edge OB. So here, friends, the slant edge OB is cut here. You can just take a vertical line from here, transfer that to the true length line. So this is the length on this true length, that is OB, where the section plane is cutting the solid. Make this measurement on OB. OB will have that measurement. And again OB is here, you will have the same measurement. Friends, OB you have marked. Then you have to mark on OD. Again, OD is not the true length. Take on this OD a line from here, it will cut somewhere here. Transfer that, you get the same measurement on this OD also. So OB we have taken, similarly on OD you should take the same distance, OD. This on OD we mark that. So friends, we have got point 1, point 2, point 3, point 4, and you remember even this slant edge OC is also cut here. OC. So OC is cut here. To know exactly where it is cutting, we have to make that line horizontal from here. That is, with this as center, this it is already parallel to that. So we can mark this point on OC. OC is here. So friends, apart from this, the slant edges OA, OF, OE, OA, OF and OE are completely available. OA, right by dot line, OF, full line, and then OE is also full line. Friends, from this O on OB, this portion is retained. On OB, we are going to have this part retained. And then on OD, also we have the same. This part is retained. We have on OC, also this part retained. And on OB, we have already marked. This is to be retained. And what is removed? The portion on OB from this point downward is removed. On OB, this is removed. So we are going to join this. This is visible. And friends, this edge is there. Since both the lines, OE and OF are there, you have to show a visible line. Again, this point you have to show till here. And friends, this will give you this portion what I have shown in dark lines will give you the development of the larger part, that is P. P is this larger part which is retained from the solid. So, friends, below this point, this does not exist. So, these lines do not exist in the development, including these base edges and again this part. Remaining all is to be shown by visible lines or dark lines as I have shown. So, friends, this is how you obtain the development. And if you are happy with the presentation I have made, please subscribe to my channel, convey this information to all your friends, and have a wonderful evening. Thank you very much.